Alright, these will be my solutions for production zone 2. Start out with terminal reclamation display. This is my low cycle solution. There's a whole bunch of drills hidden all up and behind in there to get the whole process started right away. I got this sensor pusher detection system to start to extract like this upper right module, and this left one should just get pushed out because it's I maintain it being hooked on to those two middle squares in the middle of the bottom middle one, and those get destroyed by this drill right here, but that pushes them far enough so that this intact display will make it over on that conveyor belt. And this one basically just makes it over and gets pushed out. The timing set up so that they perfectly fall in line. Here's my low footprint solution. I pretty much have 2 drills back there and 3 drills back there. It's a little slow, but I mean, that's a pretty minimal footprint. Can't really imagining it getting too much less, especially because these are always pushing forward. I mean, there might be some way to like extract this middle one without having to have these drills over here. Just moving them over here or like into some sort of different drill assembly. Might be able to reduce one, but that one's still pretty decent. Here's my low block solution. Pretty much the same thing as my low footprint solution, just with fewer drills. Alright, now shuttle maintenance. Have some drills set up to automatically remove the damaged ones. Then I have to have those pushing systems to slightly delay that in time for my arm distributor to get arms prepared. Because if I didn't have that delay, the first shuttle would get here just as 1 block too fast. So there's definitely some inefficiencies that I could still reduce so that I don't need this delay earlier in it. But this one's still pretty decent. Definitely got to revisit it and fix those delays. And my low footprint solution, the start's pretty similar. I might actually be able to have a distribution system where I weld on the arms closer to right before this, and it's like splits them out above it so it has a lower footprint. This is pretty decent. I'm probably gonna revisit this though, because I'm now seeing a couple of things I could do to optimize it even further, especially if this whole thing is above the main conveyor way, so it doesn't really use any footprint. A decent solution, but I definitely need to revisit that as well. Here's my low block solution. Basically let these stack up and only use 1 drill instead of 2 like I normally did. And there's some optimization on the belt distribution here. I lowered the input rate to compensate for the delays here. I also replaced the full pusher setup I had before with a little drop-in self-pushing mechanism. It's pretty much identical to my previous solution though. Just a couple of less blocks. I might be able to reduce it even further if I lower the input rate enough or raise it. I gotta play around with it, but I could probably remove these two. I guess I really need to revisit all the shuttle maintenance because, I mean, top tier results on most of these, but I think I could do better. Okay. Which one was this again? Oh yeah, oversight terminal. This one was a little bit tricky for my low cycle count one. Basically, it's a bunch of systems to build multiple terminals all at the same time. Spits out 2 at once with this distribution network all in here. A lot of it was just getting the timing worked out. Not entirely satisfied because I have a little bit of a delay with the sensor pusher. I think there's probably a way to do that slightly better and slightly faster, but this works. Here is my low block solution. Pretty much drop everything into place and weld it all at once. And I honestly don't know if I could optimize the timing any. I mean, I could probably remove a few conveyor belts here and there by playing around with these entry conveyor belt configuration and delaying this by one with just a block holder. I don't know, this is still a pretty good solution. I like this one. Oh yeah, that was just low footprint. This is a low block one. Okay, this one I did actually go through the process and play around with those timings. The real key was that little mechanism right there to layer it. Alright, so I'm pretty satisfied with the footprint and the blocks on that. Could probably optimize the footprint a little bit more, but could also definitely optimize the cycles, but alright. Drone maintenance. The one running at a +4. Oh yeah. So it's only running at a +4 and I run a little delay system. I'm not entirely satisfied with that, but with how that pushes that perfectly into place to fully weld them. I mean, there's not a lot else that could be done to optimize that because it goes from them perfectly touching to them being just one block apart at the end. So I'm 100% certain that this can definitely be optimized more. This works though. There's not a ton of difference. I did a couple of things different to better optimize the footprint. Oh yeah, and I have that little excess overflow so that it doesn't overflow the wrong way. This one's pretty much an identical solution, just a couple of small optimizations, like I don't have the lifter, because I didn't care about the footprint, so them spreading, and you know, there's a few changes. It's a pretty good 23 block solution, but that doesn't feel like it's as optimized as it could be. Don't think I even bothered really working on that too much. Ooh, finished studio apartment. This one is a fun one. So, yep. Starts out, does a little rotating work on that. Everything perfectly syncs up. And that little block just gives it a 1 block delay, just so that this back TV has time to go over this front TV, and they're welded together after that. Actually, not even gonna bother. There's no real difference for the low footprint and the low blocks. This one just was my base low footprint solution, and this is pretty much going to be identical, just with fewer blocks. Yeah, I might as well show both of them. This one runs a lot faster, but I attach the TV right at the beginning to minimize footprint. Past that, there's not a whole ton you can really do, because no matter what, got this giant panel that you gotta move. I got that little welder over there. I don't know if there's a way to weld both the sink and the bed, because the sink's 2 high and the bed's 1. I don't think you can really weld that above the apartment complex. Might be possible with a really complex mover pusher thing, but you'd have to drop everything into place. I could probably knock 1 or 2 off of that footprint score, but this one's pretty similar functionality, just using a couple of rotators to get the timings down. And I'm welding everything together earlier and using fewer conveyors and letting the apartments push other apartments into it. And for most of the block reduction from this came from that and the rotation instead of conveyor belts, and the splitting of every other conveyor belt for that one. Might actually be able to use a rotating delivery mechanism for the beds to reduce 1 conveyor belt. That's not all that much. Actually, do I need this? Yeah. No, I don't. Okay. So I just found... Oh, yeah, I do. Because that, otherwise the first sink falls off. Alright, so this is generally pretty optimized. And that's all my solutions for production zone 2.